Okay, this is section 9.2 with translations. And the word translation has SL in it, which also the word slide has SL, just like reflection had and flip both have FL. So translation is whenever you slide a figure in a particular distance, in a particular direction. And whenever you slide it in a particular, along what we call along a vector or translation vector, all the points have to slide the exact same amount as the vector and in the same direction as the vector. And vectors kind of look like rays, like this looks like a ray, but this vector has a specific amount, a length to it. It's called a magnitude, and it also has a direction. So if you were on like a unit circle, it has a certain degree. So we can still use our index cards to, do the same thing here. So you're going to draw a line through each vector that's parallel to, through each vertex that's parallel to the vector. So let's use this part. So this vector has a length that's this long right here. So every one of these vertices has to go that amount and in that direction. Now, it's a little tricky trying to be parallel because you have to sort of eyeball it. This isn't the most accurate way to do it, but it certainly can. So what I do is I go ahead and draw kind of light lines because it's easier to see if something is parallel when, you have the whole line there. And so the new C, the old C is here, and the new C prime is going to be exactly that length and in that direction. B is also going to be in the same direction. So if you kind of look at the side of the index card compared to the vector there, we want to go this amount. So we're sliding B all the way up to this point right here. And so this will be B prime. And then A will also be slid along the same vector by the same amount in the same direction. So if you look at this, it looks pretty parallel to that, and you stop here, and A prime goes here. Once you get that, those three new vertices, you would connect them. So A, B, and C prime. And again, the smaller your dots are, the more accurate it is. So if you'll notice, this length, this length, this length, and the vector are all the same length. So the image has been translated along that vector by that amount. All right, so let's do another one. This whole image is going to be moved in this direction by this amount. So first we need to figure out how long our vector is. And the actual length doesn't matter, like if it's so many inches or whatever. What really matters is just that you know how long it is. The vectors have names, and we put like a little half arrow above. If you'll notice, it's not like a whole arrow, it's a half arrow. That's just the name, how we name the vector. So we want this to be parallel with the vector that's down here. So we kind of line up our card as best as we can and go all the way to the end and stop. So V prime is here. W is also going to be moved in the same direction. So we're going to slide W along by the same amount. And so this is our W prime. Our U is going to be slid also parallel to the vector. Again, it's a little bit of an eyeball here. So U prime is here. And then T is also going to be parallel, same direction and same magnitude. All right, and then once you get your new locations, connect the vertices. And as you can see, the pre-image is slid or translated along this vector by this amount. All right, let's do another one. So now our vector is vector M. So this whole image is going to go up by this amount. And the vector is vector M. I'm just labeling it on my card because I have other marks here, and if I can get easily mixed up if I don't pay attention to my marks. All right, so I'm going to flip the card around this way so that I can see what's parallel. And this looks pretty parallel. All right, you're going to slide L by the exact same amount. This is L prime. J is going to be slid by this amount. And K is K prime. And then we will connect our vertices. All right, and it looks pretty good. All right, let's go to the next part. So what if you translate on a coordinate grid, okay? So if you translate on a coordinate grid, you're going to translate along a particular given vector. Notice that you'll know it's a vector because it doesn't have parentheses like a point. It has these like sort of pointed parentheses. I don't know what they're called, but anyway, so you'll know it's a vector because it has these like pointy parentheses on each side. So the first number in the vector tells you how far left or right you're going to go horizontally or along the x-axis, and then the second number will tell you how far you're going to go up or down along the y-axis, or in that case. So if I wanted to move this image, RECT, which I've drawn here, if I wanted to move it along the vector of 2, -1, 2 tells me I'm going to go, since it's positive, I'm going to go right 2. And since this is negative, it means I'm going to go down 1. So if we add 2 to each of these numbers, 2 to all the x's, and then subtract 1 from all the y's, we get our new points, and this is mapping, okay? The other thing you can do is, since you have your pre-image here, you can take each vertex and do the same thing, just don't get yourself confused. So you want to go right 2, so this E is going to go right 2 and down 1. So my E prime is here, which is that vector. That vector is right 2 and down 1. The vector actually went this way. So C would go right 2 and down 1 to C prime. R would go right 2 and down 1, R prime. And T would go right 2 and down 1, T prime. And then you can draw your translated image. Now, obviously, these ones we're doing in practice are pretty straightforward. They're a little bit simpler images. But if you use the correct methodology, then when they get more complex, then it'll make it easier. All right, so that's the vector that you move that image along. All right, let's do another one. We're going to map these points. Again, it's not as valuable in this particular case, but whenever you're translating more complicated, then it is more helpful. Okay, so we mapped our points. We want to go along this vector, so every single point is going to go right 4 and then up 5. So U is going to go right 4 and then up 5. And if you'll notice, U prime, that is the correct coordinate. V is going to go right 4 and then up 5, V prime, and T is going to go right 4, 1, 2, 3, 4, and then up 5, and then W is going to go right 4 and up 5, and then you just connect the vertices. It helps to use, if you'll notice each time I've been using colored pencils, it really helps to have your pre-image and your image in 2 different colors so you can kind of keep track of what's going on. All right, let's do a few more. This is going to be translating left 1 and down 2. So we're going to go left 1 and down 2 for S prime, left 1 and down 2 for Q prime, left 1 down 2 for R prime, and then just connect our vertices. And if you notice, the points that we arrived at match our points on our map. Now sometimes, sometimes you'll be given two images on a coordinate grid, and you'll be asked, what is the translation vector? And so you'll look at the vertices. Excuse me for the error there. You'll look at the vertices and you'll go from the pre-image to the new image. And one thing to remember is that the pre-image doesn't have primes and the new image does have primes. And so you can count and say, I went left and then down. So then you can find your vector from there. Sometimes they'll ask you to write it in this format. If they just ask you to say what was the translation, you can write it this way. If they ask you for the vector, then you would write it this way. Okay, let's look at this one. We want to go, for each point, we want to go right 3, then down 2. So right 3 and down 2 for A. Right 3 and down 2 for B. Right 3 and down 2. 1, 2, 3, 1, 2 for C. And then right 3, 1, 2, 3, and down 2 for D prime. Not too bad, actually, once you get the hang of it. You do need to know both of these methods, the mapping and the drawing, because your test may ask you to either graph it, and in graphing you should be able to do it, or it may ask you what are the new mapped points. So it's important that you know both of these methods. Okay.